In this video, we'll be talking about vectors and their direction angles. This is still 6.3. This is part 6. Okay, let's say you have a vector like 4, 4. That's its component form. It's described in terms of its horizontal component and its vertical component. It can also be described as a vector with magnitude of 4√2 and a direction angle of 45 degrees. So if you look at this picture right here, you can see here's the 4 horizontal, here's the 4 vertical, and I picked the same numbers here so that you could see at a glance that this angle here is 45 degrees. We can call that the direction angle. Usually we'll draw the vector with the initial point at the origin, so the vector is in standard form, and we'll find a direction angle from the positive x-axis in a positive direction. So if you wanted to describe a vector that moved 4 horizontally and 4 vertically, you could say that it moved at an angle of 45 degrees for a length of 4√2. So instead of describing a vector with its horizontal and vertical components, you could describe it with its magnitude and its direction angle. So in fact, this vector can be written as 4√2, and then in the component form cosine of 45 degrees, comma sine of 45 degrees, or you can write it with the standard unit vectors. 4√2, again, the magnitude's going on the outside, and then you see the cosine of the direction angle being the horizontal, and the sine of 45, the sine of the direction angle being the vertical. Now, where does that come from? Okay, so if we have a vector v, all right, with horizontal components a and b, so this measures a and this measures b, we are looking at a right triangle. The hypotenuse would be the magnitude of the vector. So the magnitude of v, all right? And here's what I was just saying. You could write it in this other form. You could put the magnitude on the outside and then put the cosine of the direction angle, comma, the sine of the direction angle. Or here it is with the standard unit vectors. All right? You could distribute that magnitude of v inside the parentheses here or inside the component form, but it's a little cleaner to keep it on the outside. Now, why is this true? It just goes back to SOHCAHTOA stuff because this is a right triangle. Right? If you think about it, the cosine of the direction angle theta, that's going to be the adjacent side divided by the hypotenuse. So a divided by the magnitude of v. Sine will be the opposite divided by the hypotenuse. So b divided by the magnitude of v. And if you solve for a and b, you will find that the horizontal component is the magnitude times the cosine of the direction angle. That is the horizontal component. And the vertical component is the magnitude times the sine of the direction angle. All right, so it has a nice pattern. Now, if you need to find the direction angle, you're basically going to be using tangent. All right. Because if you know the horizontal and the vertical components, if you know a and b, then you know the opposite and the adjacent side for the direction angle. So what you know to be true is that the tangent of theta will equal b divided by a. And then to find the direction angle, you're going to use the inverse tangent or the arc tangent. But you will have to consider the quadrant. Because in general, when you have tangent of theta equals a real number, there are an infinite number of solutions. When you use inverse tangent or arc tangent, that's a special function, and its range is restricted between negative pi over 2 to positive pi over 2 or negative 90 to positive 90. So it may not give you the direction angle directly, right? Now, do keep in mind, typically when you're doing the direction angle, these are how they will limit it. between 0 degrees and 360 or 0 and 2 pi. That's not a hard and fast rule, but that's mainly what your book will be using. Okay, so let's say we have this vector and we need to find its direction angle. Okay, so what you'll be solving is the tangent of theta equals 2 divided by -8. This is A comma B, this is B over A. Tangent of theta is equal to B over A. So then you're going to be looking at theta being equal to the inverse tangent. Now this is a little tricky, maybe I should say theta prime. There's an infinite number of angles whose tangent value is -2/8. All right. Now, when you do inverse tangent using the calculator, it will give you -14.04 degrees. All right. Remember, inverse tangent will always give you results between -pi/2 to +pi/2, or if you're doing degrees, -90 degrees to +90 degrees. Okay. So if you think about it, the absolute value of this is actually going to be a reference angle for your true direction angle. Look at the picture and you can see this a little bit better. So here is our actual vector that we're supposed to be finding the direction angle for. It is -8, 2. So if you started at the origin, the horizontal is -8, the vertical is 2. All right, the direction angle for this, measured from the positive x-axis, right, is going to be more than 90 but less than 180 because this is in quadrant 2. So the direction angle needs to be more than 90 but less than 180. And then if you look at what the calculator gave us, it said -14 degrees. That's not in here at all. Basically, -14 degrees is here. All right. Okay, so using the absolute value of that, we're talking about +14 degrees. That's going to be our reference angle for the one we're really trying to find. So this angle here is 14 degrees or 14.04, I don't know, 2 decimal places. And so the actual direction angle that we're going to use is here. So we're going to do 180 degrees minus 14.04 degrees. Okay, and then that will give us the result of 165.96 degrees. That's our true theta or direction angle. Okay, now this was -8, 2, and it was in the third quadrant. If I switch it around so that it's +8 and -2, I'll still be working out basically the same equation. Tangent of 8 equals -2/8. And so when I do the inverse tangent on the calculator, I'm still going to get -14.04 degrees. Okay, now I want an answer that's between 0 and 360. We're restricting ourselves to positive answers, so we're not going to be able to use this. Now, always think about the quadrant. So when you're looking at something here with a positive horizontal component and a negative vertical, that's like positive x, -y, this is going to be quadrant 4. Right? So if you draw a graph of that, that makes it even clearer. Quadrant 4. So our direction angle is going to be, remember we're measuring positive, we're going around this way. It's going to be greater than 270 but less than 360. Right? We can use that absolute value, 14.04, as a reference angle. So if I draw in the reference triangle, right here, this is 14.04, and then I can find that one by doing 360 minus 14.04 degrees. And that will be 345.96 degrees. All right, so always make sure that the quadrant makes sense. All right, one last type of problem that they'll ask you to do. Okay. All right, find the component form of the sum of vector u and vector v with direction angles theta u and theta v. Okay, so vector u has a magnitude of 8, and here's its direction angle, 30 degrees. Vector v has a magnitude of 5, and its direction angle is 270 degrees. All right, you don't really have to draw a graph of this, though it could possibly help you picture it. Basically, you're trying to find the sum. You're trying to do u plus v. All right, so if I write these in their component forms, u is going to be 8 times cosine 30 degrees comma sine of 30 degrees. V is going to be 5 times cosine 270 degrees comma sine of 270 degrees. So basically, I can just work out what the sine and the cosine are of each one of these angles. So these are special angles, so I don't need a calculator. The cosine of 30 degrees is √3/2. The sine of 30 degrees is 1/2. The cosine of 270 degrees is 0, and the sine is -1. And then if I multiply by the magnitudes, vector u, this is the component form of vector u, written with its horizontal component and its vertical component. So 4√3 is the horizontal component, and 4 is the vertical. For vector v, the horizontal component is 0, and the vertical is -5. And then to add these together, I just need to add the two horizontal components. So 4√3 plus 0, that'll just be 4√3. And then add the verticals, 4 plus -5, and that'll be -1.